Hello, hello, welcome back to Geometry. We are in Chapter 9, Section 7. We're talking about law of sines and cosines. So if we have a triangle like this and you know some information about these sides and you want to find the area of a triangle, well, let's first establish that the area of a triangle is 1/2 base times height. Okay, well, in this triangle, we don't know what the height is. But I can find the height. If I know this angle right here, let's say I know angle A, I can find the height. The height would be right here in a right angle. That would create a right triangle here, and so I could use sine A, which is opposite, which is the height, to hypotenuse. So opposite would be the height to the hypotenuse would be C. Okay, so I could find the height by multiplying each side by C times C. That would cancel out the C here, and then I would get the height is equal to C times sine A. Now, if I go back up here, I don't know the height, but I do know that the height is C times sine A. So now I can plug that in for the height and say the area of a triangle is 1/2 times B, we use B as the base, times C times sine A. Now this works with any two sides and their included angle. So I could go over here and say I could use sine C, use two sides and their included angle. I could also use B. So I could also say 1/2, and in this case, A times B times sine C, or 1/2, use the two included sides here, A times C times sine B. Okay, so you can do this anywhere if you have two sides and an included angle. Alright, so if you have two sides and the included angle, you can find the area with this formula. Alright, let's find the area of this triangle. Look at that. Conveniently, we have two sides and the included angle. So the area is 1/2 the product of those two sides, 19 times 17 times sine A, sine 135. Type that in and you get an area of approximately 114.2, 14.2, and that's whatever units we're using squared. Alright, now when you know two sides and the non-included angle, so side-side angle, or two angles and a side, as an angle-side angle or angle-angle side, you can use the law of sines. The law of sines says that the ratio of one angle to its opposing side is equal to the ratio of another angle and its opposing side. So sine A to the opposing side is the same as sine B to its opposing side, which is equal to sine C and its opposing side. Now you can write that ratio either way. You can write it with the sine and angle on top and the side on bottom, or you can flip all those upside down and write the ratio this way around, whichever way is more convenient for you to solve. So let's look at this triangle right here. We know two sides and a non-included angle. So we can set this up. We can say sine A to side A is equal to, and we want to solve this, we have sine B over side B. So sine A would be sine 115 over 20 is equal to sine B over 11. I'm going to multiply each side by 11 times 11. So I get sine 115 times 11 over 20 is equal to sine B. Type that in and you'll get that sine B is 0.498 and so on equals sine B. Now that's sine B, that's not the measure. Now if I want the measure of the angle, I need to do inverse sine for this. So I'd have to basically multiply each side by inverse sine, multiply this by inverse sine. Okay, so now you do inverse sine of 0.49, and then you get, that cancels out the sine, and you get the measure of angle B is equal to approximately 29.9 degrees. Now once we have that, then we can say, okay, well, 180 minus the 115 minus the 29.9 leaves us with 35.1. So now we have all the angles, 29.9, 35.1, and 115, 3 angles. We have 2 sides. We could use Pythagorean theorem, or we could keep using the law of sines, because we're having so much fun with it right now, we'll use the law of sines. So I can set that up, say C, because I'm looking for C, I'll put that on top, to sine C is equal to A to sine A. Alright, plug in. We don't know C, but we know sine C. Sine 35.1 is equal to, and then here we have 20 over sine 115. We want to cross multiply here. Bring this up there, so you get C is equal to 20 times sine 35.1 over sine 115. Type that in, and then you get C is about 12.7 units. Alright, solve the triangle. Round decimal answers to the nearest tenth. Similar procedure, except now we know 2 angles. So we're going to set up our proportions. Actually, we have 2 angles, so let's first find the third one. So we have 180 minus 107 minus 25 gives us 48. Because now we can set up the all 3 of these in one. Okay, we want to know A. We know that B is 15. We want to know C. And then we know A is 48. B is 25. And then C is 107. Okay, so here if I want to solve for C, I'm going to cross multiply and bring this up here, so then I'll have 15 times sine 107 over sine 25 equals C. On this side, if I want to find A, I'll have A is equal to, and then cross multiply, this was a 40, so 15 times sine 48 over sine 25. Type those in, you get A is equal to approximately 26.4 and 26.4, and C is approximately 33.9. Alright, there we go. Alright, a surveyor makes measurements shown to determine the length of a bridge built across a small lake from the North Picnic area, from right here, to the south picnic area. All right, find the length of the bridge. So this right here should be the length of the bridge. We're given angle, side angle, so let's set up our proportions here. We have the side in between the two angles, so that's nice. Now we can find that third side first. That's going to be 49 right here, so I can set those up. Sine, everywhere a sine, here a sine, there a sine, everywhere a sine. Okay, so sine A, 71, sine B, 49, and sine C, 60. Okay, that's C. We know that B is 150, and this is A. We are looking for C, so we're going to use this proportion right here. Cross multiply, bring sine up there, 150 times sine 60 over sine 49, sine 49. See? Type that into your calculator and you get approximately 172.1. Now, if you know all three sides of a triangle, or two sides and their included angles, so side angle, side, you can use the law of cosines. The law of cosines looks like this. It's a little crazy, so let me cover up these first. Okay, so looking at it bit by bit here, right? First, we have a squared equals, notice on the other side we have b and c. A squared equals b squared plus c squared minus 2bc. The same things that we had here, bc, bc, and then cosine of what we started with, cosine A. Okay, the others follow the same pattern. So if you start with b, b squared equals a squared plus c squared minus 2ac, these two again, and then cosine of what we started out with, cosine b. Okay, and the third one, you would guess it, c squared equals a squared plus b squared minus 2ab, cosine c. All right, let that sink in a little bit. Copy that down to your notes, and then we will look at a problem. Okay, here we know two sides and an included angle, side angle, side. So we know we know angle B. We're looking for measure B. All right, so we'll set this up using b squared is equal to, okay, we'll use the other two, so a squared plus c squared is equal minus a 2ac times cosine b. All right, let's plug that in. B squared is equal to 11 squared plus 14 squared minus 2 times 11 times 14 cosine 34. All right, so we can evaluate this, find the square root. B is equal to the square root of all this. That's 317 minus 308 cosine 34. Now that comes out to be approximately, they said round to the nearest tenth, 7.9. However, when we're going back and finding the other angles, it's important to either use this expression to be exact, or when we got that, we got something like 7.8521. So using this, we could type that in, say, we can use the law of sines here. Plug this in, solve, find the inverse sine, find measure of angle A, and then find measure of angle C. Now, if you know all three sides, we're going to plug it in, and we first want to find the angle opposite the longest side, so we'll plug that in. Solve that for cosine B, and then the inverse cosine will give us a measure of 112.7. Then use the law of sines to find A, and subtract from 180 to find C, and there you